Hello, I welcome you to the channel Microwave Testing, which is focused on the non-destructive testing using microwaves. If you want to learn on the technical basics of microwave testing, then you are right here. We have already seen the results when moving a microwave test head over a defective part, like this here. We had obtained these results, a kind of hook for defects which are near to the surface of the part, and a hook with spirals at the root for defects which are located deeper in the part. Today we will learn how the shape of such indications form. Normally, such defects are within solid material. But for simplicity, today we will assume a defect which is in air. That means a small solid particle in air. Here we see the defect. Here we see the transmit-receive test head with the antenna. This block we will have to move along this line and see what happens. Well, the transmitter in the test head through the antenna is radiating into all directions. One ray hits the defect and is reflected back and received by the receiver, and the receiver gives a signal representing the amplitude and the phase of the reflected signal. Well, the phase, you remember, is a measure for the length of the travel path, that is forth and back. Normally a length is given in meters. We can give it also in number of wavelengths, and considering that one wavelength is 360 degrees, we can that also give as a phase in degrees. And then we can plot the received signal, the reflected signal, in this circle diagram. This is the point reflecting the measured reflected signal. The distance from the center is proportional to the amplitude, and the phase, you remember, because of delay it is negative, is just this around here, in this case approximately minus 200 degrees. Well, we will now look at the situation when the TR test head is moved along this line. Therefore, we will here see a more elementary sketch. And on the right hand side we see the diagram of the reflection coefficient. We see both of them and we can see the difference in a few seconds. Now we start moving this test head. This is the first value, and now further values follow, where we see here the difference. This one gives the momentary value, and this one gives the trace. That means also the stored values from before. We continue the movement, and the length of the travel path becomes shorter. That means the because of the radiation attenuation is becoming smaller, and the amplitude is becoming larger, and the phase is also becoming less negative, that is more positive. There we see it goes into the negative clockwise, which is positive mathematical direction. Here we have the situation where the distance between the test head and the defect is minimum. That means the amplitude is maximum and the angle is less negative, that means most positive. Continuing, we have a mirroring effect, mirror of the situations to the right, but to distinguish it, I have made it here in red color. Then we are back and we see a spiral has been evolved, a spiral in this case of somewhat more than 1.5 turn. Well, such an antenna does in practice not radiate into all directions, but such an antenna has a limited beam width, and we have to consider that, and that is done in the next series. Here the antenna beam width, some antenna beam width is sketched. Here is the defect, and the antenna does only radiate into this angle section, and no radiation is incident on the defect, and no radiation is reflected. So we have a zero indication in these both diagrams. Well, we move the antenna and the situation does not change until there is the defect inside the radiation beam. Then we get a signal, non-zero signal, and we continue as long as the defect is in the radiation beam. We get a new signal, and then it's zero and no addition. Oh, what's that? Okay, there we are at the end, and we see we have some hook with a little bit of spiral of the spiral here at the root of this hook. Well, this here is a situation where there is a significant distance between the line where the test had moved and the defect. We can also consider the situation where the defect is more near to this line, and that we will do in the next series. Here the defect is situated near to this line, and we will move the test head, TR test head, and it takes longer that there occurs a signal only here, and in this case only 3 of these steps give a signal, and that's all what we can see here, only a hook without some rounding or spiral at the root. Summarizing, we note that the shape of the trace of a small defect's reflection depends on the antenna characteristics and on the depth of the defect. Especially, the larger the depth, the more the formation of the spirals. In the next video, we will discuss the situation when the defect is within solid material. So far for today. Until next time. If you liked this video, then please share it. Goodbye.